Assalamualaikum and good day to Sasalim. My name is Nur Shakira binti Azmi. Together with my group mates Saada and Diana, we will presenting our project Fuzzy Logic System for Student Academic Performance. Most traditional academic evaluation system use strict rules like pass or fail, but this does not really reflect how students actually learn. In real life, student performance does not suddenly change from low to medium or high. It improve gradually. For example, a student who studies for 4 hours per week is labeled as low performance, while another who study 5 hours is considered medium, even though the difference is very small. This kind of sharp boundary is not realistic and can be unfair. Traditional system also cannot handle uncertainty or situations where a student fall between two categories at the same time. Because of this, academic risk evaluation may not be accurate. To solve this problem, our project used fuzzy logic system to predict risk level, low, medium, or high, based on early indicators such as study time, absence, and first period grades. This approach helped identify students who may need help earlier, so timely academic support can be provided. Based on Journal Azmin et al. 2025 proposed a fuzzy logic approach to predict university students' mathematics performance, especially for Calculus 1. In their study, a fuzzy logic system was developed using MATLAB with input variables such as attendance, study hour, and exam score. The results show that the system was effective in predicting student performance, and exam score were identified as the most influential indicator for early detection or struggling students. This study demonstrates how fuzzy logic can handle uncertainty in academic data and support early invention, which align closely with the approach used in our project.
Assalamualaikum, my name is Nur Saada, metric number CA2409, and today I'll be presenting about one of the article that related to our project, which is analyzing student academic performance based on fuzzy inference system by Ergin and Nasibov. So this article discusses the problem of evaluating student academic performance using traditional method. So normally, student performance is assessed using fixed numerical score and strict boundaries which do not reflect real learning behavior. So students often have mixed abilities and their performance cannot be clearly classified using crisp value. So to solve this problem, the author proposed using a fuzzy inference system. So fuzzy logic allows student performance to be described using linguistic terms such as low, medium, and high. So instead of we use strict numbers, so this makes the evaluation more flexible and closer to human reasoning. The system uses fuzzy if-then rules and membership function to analyze student scores and classify performance level. So the author used a Mamdani fuzzy models, which is easy to interpret and commonly used in decision-making system. So the results show that the fuzzy system can classify student academic performance more smoothly and realistically compared to the traditional method. It also helps educators understand student strength and weakness more clearly.
Assalamualaikum, my name is Nurlana Nabila binti Muhammad Yatim and my matrix ID is CA24076. So today I want to explain about literature review summary for the forecasting student academic performance using NeuroFuzzy model. They combine fuzzy logic with neural networks, a NeuroFuzzy model to predict student performance. This hybrid approach is better at handling unclear or complex student data and gives more accurate prediction than traditional methods.
Okay, right now I'll be presenting about system architecture for our project. So our system architecture show how the Fuzzy logic system works step by step. First, the system receives student data such as study time, number of absent, and first period grade. So these values are numerical and called crispy input. Next, the fuzzification process convert this number into fuzzy values like low, medium or high. After that, the fuzzy rules are applied. This rule acts like decision guideline that combines study habits, attendance and grades to evaluate academic risk. Then the inference engine process all the activated rules and combine their result. Finally, the diffusification process convert the fuzzy result into a single numerical value that represent the student's academic risk level. So overall, the system takes student data, reason like a human, and produce an academic risk prediction. Logic flow diagram. Okay, right now I'll be presenting about our logic flow diagram. So the logic flow diagram show how the fuzzy logic system makes a decision step by step. So first, the system start by receiving student data such as study time, absence, and first period grade. So next, these input values are converted into fuzzy values like low, medium, or high. Then the system check all the fuzzy rules one by one to see which rule are activated based on the student data. After that, the result from all activated rules are combined together. Finally, the system convert this combined fuzzy result into a single value, which represent the student academic risk level. So the logic flow diagram help us understand how the system move from student data to final academic risk decision in a clear and structured way. Okay, right now I will explain about input and output variable. So, the input variable represent the key academic factor that influence a student performance. So, in this system, we use study time, number of absent, first period grade, which is G1, as an input. So, study time reflects the student learning effort. Absence indicates attendance behavior, and G1 represent early academic performance. So these input were chosen because they are strong indicators of whether a student may face academic difficulties later. So the output variable is academic risk level, so which represent the likelihood of a student experiencing academic problem. So instead of giving a simple pass or fail result, the fuzzy system classify risk into a low, medium or high, allowing more flexible and realistic assessment. This help educators identify students who may need or not early student support rather than waiting until their final result.
Next is fuzzy inference process overview. For Mamdani type fuzzy inference system, which is FIS, use purpose to predict student academic performance risk level, which is for the input variable is study time, number of absence, and first period grade, which is G1. For the output variable, academic risk level, the main piece is fuzzification, rule evaluation, and aggregation and diffusification.
Okay, so for the numerical part that I participate is fuzzification. So right now I'll be presenting about fuzzification of our project. So fuzzification is the step where we convert numerical student data into fuzzy values. For example, if a student studies 2 hours per week has 18 absence and scores 9 in the first test, these numbers are not used directly in decision making. So instead, each value is mapped into linguistic term like low, medium or high using membership functions. For absence, a value of 18 belong mostly to the low category, but it also partially belong to the medium category. Similarly, a G1 score of 9 is mostly considered low, with some influence from medium. So this means that the student does not belong to only one category. Fuzzification allows the student to be partially low and partially medium at the same time, which reflect real academic behavior. So these fuzzy values are then used in a rule evaluation process.
In this slide, we explain the rule evaluation process in our fuzzy logic system. After the input value are fuzzified, they are evaluated using a set of predefined if-then rules. Each rule represents expert knowledge about student academic behavior. During this process, the logical AND operator is implemented using the minimum method, while the OR operator uses the maximum method to determine the firing strength of each rule. This firing strength indicate how strongly each rule is activated based on input condition. Multiple rules can be activated at the same time, allowing the system to evaluate complex academic situations more realistically rather than relying on a single rigid rules.
For the aggregation and diffusification, aggregation has 3 academic risk level, which is high risk, medium risk, and low risk. For the aggregated result shows a stronger tendency toward high academic risk, while still retaining some influence from the medium risk category. For the diffusification, the final decision based on the output value, academic risk score is 68 and classified as high academic risk. This indicates that the student is likely to face academic difficulties and may require early academic intervention. For the conclusion and discussion of this project, FUSI system evaluates students using multiple indicators simultaneously and handle uncertainty and borderline case effectively, produce smoother and more realistic risk classification, and the last one is suitable for early detection of students needing academic intervention. That's all from me. Thank you.